From chaos to consciousness, the mystery of life's beginning. If, in an instant, you could magically transport yourself back to Earth 4.5 billion years ago, barren, volcanic, and lifeless, and then, in the next instant, you return to the Earth we know today, teeming with diverse ecosystems and intelligent life, you would almost certainly conclude, only magic or a supernatural force could have achieved this transformation. Yet, modern science offers an explanation grounded not in magic, but in evolution by natural selection, a process that unfolded over billions of years. But evolution explains only the diversification of existing life forms. It does not explain how life first began. There had to be a starting point, a seed of some kind. That first spark of life must have emerged from a primordial soup, a blend of non-living chemicals. But how? How could basic processes of geology, chemistry, and physics arrange themselves so precisely to create living matter from non-living material? To many, this seems impossible. Bust in silhouette, was there a blueprint? Some argue, there must have been a blueprint. There must have been an architect. How could such a vast, functional, and beautiful diversity of life emerge from random collisions of atoms? And how could it have happened all on its own? That's exactly what we'll explore right now. Microscope, what is abiogenesis? Abiogenesis is the scientific hypothesis that life originated naturally from non-living matter under specific conditions, like in Earth's early oceans, powered by energy sources such as lightning or hydrothermal vents. Unlike religious creation theories, abiogenesis does not rely on a divine intervention. It investigates how chemical pathways could have produced life, RNA, proteins, and membranes assembling on their own from raw elements. In short, the origin of life from inorganic material is what we call abiogenesis. Scroll, what do Abrahamic religions say? Let's contrast that with religious accounts. Brown circle Islam. Adam was created by Allah from clay. Hawa, Eve, was created from Adam's rib. Life was breathed into Adam by God. White circle Christianity. A Genesis describes God creating Adam from dust and breathing life into him. Eve was made from Adam's rib. Both religions claim that life came from non-living substance, but with divine intervention. However, neither provides any step-by-step mechanism for how that life arose, unlike the abiogenesis model. Yet ironically, both narratives also skip over the issue of complexity, assuming that a fully formed human can emerge from clay, without discussing the deep design and intelligent structure that life entails. Religion invokes magic. Science invokes chemistry. Science treats life as a complex biological recipe, one that might one day be fully recreated in laboratories. But despite decades of research, no lab has ever produced a living being from non-living material. Even in specialized cancer hospitals, with all our advanced knowledge, we see more suffering than solutions. Yes, science is inching closer. Yes, it recreates certain steps of life in the lab. But it hasn't created conscious, self-replicating life from scratch. The creator and the laws of nature. Science often presents ancient religious ideas like life coming from dust in modern chemical terms. But factories don't build living beings. Mountains and rivers cannot be manufactured in a lab. They emerge from universal laws. Scientists tend to deny the possibility of a supreme intelligent creator. But let's be clear. This creator is not the God of any particular Abrahamic religion, which often looks more like a family business than universal truth. Instead, the true intelligent creator, if such exists, must operate within the framework of universal laws. That's what makes the creator intelligent. Not supernatural trickery, but precise design using known principles. Consider the airplane. It works every time, if the conditions meet the laws of physics. So too does the solar system. But what's most astonishing is not just the sun, but the placement of Jupiter as a protector, and the moon as a stabilizer. These are not random accidents. In fact, the moon's presence appears so purposeful that I propose. New moon, the moon was intentionally placed by an intelligent creator. A correction mechanism for Earth's evolution. This forms the basis of my own theory of correction, which I will elaborate in my upcoming video. Atom symbol abiogenesis versus evolution. Before we go deeper, let's clarify, abiogenesis is not evolution. Abiogenesis is about how life started from non-life. Evolution is about how life changed and diversified over time from earlier forms. So what did life begin with? At the core of every living being today are three basic components, what I call the trinity of life. 1. Nucleic acids, DNA/RNA, the blueprints for life. 2. Proteins, molecular machines that carry out vital functions. 3. Lipids are the fatty molecules that create cell membranes. Before even the simplest life could exist, these three components had to be present. Lipids, the skin of life. Some scientists believe lipids were the most important starting point. Why? Because without a membrane, a boundary, there would just be a chaotic soup of molecules with nothing organizing or protecting them. But with lipid membranes, it's possible to encapsulate elements that could begin interacting in meaningful ways, eventually forming life. Lipids are unique. Each molecule has the hydrophilic head, loves water. The hydrophobic tail, hates water. When in water, these lipids self-assemble into spheres, where the tails hide inside and the heads face water, just like modern cells. That's their natural tendency. And contrary to old beliefs, lipids can form from non-living materials. Experiments show that heating carbon monoxide and hydrogen with Earth-like minerals can create lipids. So they could have formed in early Earth's hydrothermal vents. But here's a challenge. In salty oceans, these lipid spheres fall apart, especially when salts or magnesium ions are present. And yet, for RNA to work, salts and magnesium are required. This was a paradox. But in 2019, researchers at the University of Washington made a breakthrough. When amino acids, building blocks of proteins, are present, the lipid spheres don't fall apart. Even better, the lipids help concentrate amino acids inside them, potentially triggering further reactions to form proteins. This means lipid membranes and proteins likely formed together, protecting and enabling one another's existence. What about RNA? RNA is likely the first self-replicating molecule. It plays a central role in expressing genetic instructions today and is simpler than DNA. That's why scientists favor the RNA world hypothesis, the idea that RNA came first. But how did RNA form? RNA is made of ribose sugar, phosphate groups. Creating these bonds in the lab has proven extremely difficult. In living cells, complex enzymes are needed to assemble RNA. But life didn't start with enzymes. Still, in 2009, researchers showed that clay surfaces can act as catalysts, helping RNA components link together. In 2017, scientists from McMaster University and Max Planck Institute showed that organic molecules from meteorites could have landed in shallow ponds, where wet-dry cycles enabled RNA formation. They even dated this to around 4.17 billion years ago. So we now have plausible pathways for both lipids and RNA. But what about proteins? Petri dish proteins and the Miller-Urey experiment. Back in the 1950s, Stanley Miller and Harold Urey showed that organic compounds, including amino acids, could form under conditions simulating early Earth. So the building blocks of proteins were almost certainly present early on. And we know that the Earth had billions of locations, oceans, vents, lakes, where these molecules could interact trillions of times over millions of years. Is it all just probability? Critics say the odds of life forming by chance are like throwing a watch into a blender and hoping it reassembles. Astronomers Fred Hoyle and Chandra Wickramasinghe estimated the probability of all the chemicals in a simple bacterium assembling by chance as 1 in 10,40,000, a number more than the atoms in the universe. But this analogy is misleading. Life didn't start as a complete watch. It began with a few functional parts. It didn't need to all happen at once. It unfolded in small steps with massive time and material to try again and again. For example, Earth's oceans have 4 times 10 to the power of 47 molecules of water. Even if 1 in a million was an amino acid, That's 10 to the power of 41 amino acids interacting everywhere, constantly. So the real question isn't whether all parts came together perfectly, it's whether a few parts came together plausibly and slowly evolved. Repeat button from chemical to biological evolution. But how did chemicals evolve into biology? That's still unclear. Chemical evolution isn't driven by natural selection like biological evolution. But in 2014, MIT physicist Jeremy England showed that thermodynamics might hold the answer. He argued, when molecules are exposed to energy, like sunlight, they naturally rearrange themselves to dissipate energy more efficiently. Over time, this leads to complex structures, even life. Supporting this, a 2011 study showed that DNA and RNA absorb ultraviolet light better than any known molecule, hinting that their very structure evolved to serve energy dissipation. End arrow. Final thoughts. We do not yet have definitive proof for how life began, but we do have plausible pathways showing how simple chemistry could have led to biology. Abiogenesis may remain a mystery, but not a miracle. It's a scientific journey still unfolding. Meanwhile, it remains valid and perhaps essential to ask whether an intelligent creator, one operating through the laws of nature, played a guiding role. Our understanding evolves just as life did, from humble beginnings to deeper knowledge. And that pursuit, driven by curiosity, is perhaps the most divine force of all.